Right, guys, a very warm welcome on a Sunday morning. Thank you all for joining in today for the linear regression using case study in our workshop. The consultant who's going to be delivering this workshop is Mr. Subhajit. He has worked across multiple regression models, and he's been working with a large analytics firm as well. So I'm going to give the mic to him, and he's going to take it forward. Thanks, everyone. Just for your information, we have muted everyone just so we do not hear any background noise from anyone's mic. But you can still chat. You can still ask your question through the chat window. So feel free to ask questions through the chat. Thank you.
Hello everybody. So I'm Shubhajit. So today we are going to discuss about a modeling technique which is known as regression. So some of you must be knowing what is regression, but nonetheless. So we are going to first I'll just talk about little bit about the theory and followed by a case study. We are also going to do a case study. Let me start my presentation just by asking you a question. What is regression? Okay, this is a very basic question, but again, I do not want a definition. I mean, this just for your wit. Just can you sum it up with one word? What is regression? Prediction. Okay, but their prediction could be a lot of things as well, but only regression. Okay, I call it. Okay, this is my definition. Okay. So since the festival is round the corner, so let's start off with a romantic note. It's a relationship. Okay, it's a relationship. Indeed, it's a relationship. Exactly just like the relationship what you guys are having on Facebook. Exactly like that. Now, it's a relationship, but not between two human beings, between two set of numbers. I'll tell you what I mean to say. Now, if I ask you to, yes, Snehashish, actually, can you hear me, Snehashish? I just hope you can hear me. Everybody can hear me, right? But probably you cannot talk to me back, but you can write on the screen. I can see that. We have muted just because of the background noises. Well, now I was telling about relationship. When I say relationship between two set of numbers, I mean to say, okay, if I ask you, what is the relation between sales and price? What if I increase the price? What will happen to the sales? I mean, I'm not judging your intelligence, you all must be knowing, but tell me, here's a question. What will happen to the sales if I increase the price? Sales will decrease, absolutely. But how did you tell that? From your experience, right? How about if I tell you, okay, this is the relation, okay? If price goes up, sales goes down, kind of relationship most of us having with our bosses. Our boss is, I mean, unhappy, we become more happy, okay? However, this has been known to you from your past experience. But if I tell you what's going to happen if I increase helix loop helix, what's going to happen with neurofibromin? Have you heard about these words earlier? So I just Google it out. These are names of some genetic cells of human body. Okay, even I don't know what's going to happen, but this is what you didn't know. So something you are not knowing from your past experience, unlike sales and price. But regression tells you what will happen. I mean, what is the relationship what you are having between sales and price, or neurofibromin and HLH. Okay, if one increases, what happens to the other? It also increases or it decreases. This is the relationship what we can find out. But I mean, if you are okay to find out a relationship, don't you feel that it would have been much more beneficial for you if you had known how much decrease or how much increase has taken place? So if you want to quantify that, how much, okay, if I increase the price by how much, and what is going to the effect on sales then? This is the essence of regression. Regression first tells you two things: whether there is a relationship. If there is a relationship, what is that? If I increase one, if the other also increases, that means there is a positive relationship. And if I increase one and the other decreases, then there is a negative relationship. The relationship it tells me, what is the relationship it tells me, and moreover it also quantifies. If I increase the price by 10 unit, what is the amount of sales I'm going to lose out? Okay, both the things I get to know. So you must be thinking like that when I said, okay, neurofibromin. Nonetheless, now let's suppose this is the quantification out of a regression equation I receive, that if I increase the price by 1 unit, let's say sales will be reduced by 2.5 units. But don't worry, that's not the way it is shown. I just showed you just to explain you. So if I multiply price by 1, sales will be reduced by 2.5. But actually on your screen, on your regression equation in the software, it will be so this is the relationship I talked about. So when price is increasing, sales is decreasing. So this is how it will be shown. Sales, there will be nothing written on sales because we are trying to predict the sales. And with the price, we know that if price is increased by 1 unit, so sales will be reduced by 2.5 units. So it will be written in this way, that minus 2.5. That means if you increase the price by 1 unit, sales will be reduced by 2.5 units. Since it is reducing, that's why it will show you a negative value. Okay. By the way, the 2.5 by which sales is reducing or increasing, whatever may be the case, is known as coefficient. I'll be referring them henceforth as coefficient. This is just a name. However, now you just tell me, can we have such a scenario where I increase the price, okay, and the sales remained as it is, did not change? Can we have such a scenario? When? Yes, but then sales will be reduced. Monopoly goods, that's correct. That monopoly goods, and maybe, I mean, that is the correct answer of my question. Uh, yes, when demand is more, just like onion. The onion has become 70 rupees a kilo. But have you luxury items? No, actually. When you increase the price, the sales will remain same in luxury item, not really. Sales is definitely going to fall. Okay, could you please just keep your mic on a mute? So we are just having a lot of background sound. Yes, coming back, yes, absolutely, in case of onion. Okay, so even if your price is increased, sales is not going to go down. Now, as you are asking me, that would have been my next question. What if I increase my price and my sales goes up? Yes, from your medicine, yes, definitely. But in terms of medicine, there could be other medicines as well. If the price of calpol goes up, probably you're going to go for crocin. So, I mean, so you understand the concept. So we're actually not getting into the debate of what is what, but you understand the concept, right? Now, as I was saying, what if for a scenario I you know increase my price and my sales goes up as well? So you said festival, right? In terms of festival, anything else apart from festival? Anything else? Let's suppose we do not have any festival whatsoever, but still I increase my price, but still my sales also goes up. Well, it is not a monopoly market. Let's say it is not a monopoly. Income. They were on saying income. Uh, well, income definitely could be a point. Definitely could be a point, but we are assuming that not all of ours income is going to rise. Inflation, but inflation doesn't push your sales up. It pushes the price up. For just listen my scenario. There is no festival, but I increase my price, but my sales also goes up. Why? Think of a scenario. I'll give you an example. Let's suppose, I'll give you one of my favorite example: chicken and mutton. I just cannot stay without non-veg. How, I mean, what if your mutton price goes up, let's say 600 rupees a kilo, and the seller of your chicken, he finds an opportunity, he makes the chicken 200 rupees a kilo. Still you're going to buy chicken more, because you do not have any other option. The competitor product, who has actually increased the price even higher. Or should I give you a much more relevant example? Let's talk about your some soaps. Okay, Dove soap of Unilever. Who are the competitor of Dove? I'm not an expert in beauty soap, so I do not know, don't recall all the brand names. But let's say P&G and all the other brands are there. What if your competitor has increased the price even more? So even if you have increased the price, people still are going to buy from you. Yeah, please come. So these are the scenarios. So the essence of harping on the same point is, so actually we know sales is actually not dependent only on price or only on festivals. So these are influenced by a different multiple number of factors. Sales could be influenced by your own price, by your competitors' price as well, okay, by your promotions. Different types of promotions are going to influence definitely your sales. What else? Seasonality. Seasonality is your festival, maybe the rainy season. Even if you don't do anything with your price, your sales are going to go up in case of umbrella during the rainy season. Does that mean that you have done promotion? Does that mean that you have decreased the price? No, but still it has an effect. So if I say the sales has gone up, it could be due to your price, it could be due to festival, it could be due to multiple factors like both price and festival. So regression analysis also helps you to understand that if 20 units of your sales has gone up, then how much among those 20 additional units which you are selling, how many units of them have gone up due to only price? Because 20 units has a combined effect. has a synergy effect of both price and festival. Let's assume we have only two variables, price and festival. So how many of them are attributed or are propelled only by price, and how many of them are propelled only by festival? What else we have? Another variable apart from price and festival, there is something we called as base sales. Base sales means even if you do not have any festival, even if you do not promote, even if you do not decrease or increase your price, still you are going to make some sales. Some people are going to come to your store and buy it, right? That we call as base sales. Even if you do not have any effect of these variables of price or festival, but still some sales you are going to have. That is your base sale. Any questions so far? Anything? May or may not be. Your base sales may be zero. If you, I mean, it depends on the product. It depends on the market. It might so have happened that even if you, I mean, if you do not actually give any promotion, you are not going to have any sales. Can you think of a situation of such a scenario? You know, my problem is when you ask me some question, I ask a question back to you. I have a bad habit. So can you think of any scenario? I mean, anything, any wild guesses? No penalization for wrong answers, no chocolates for the right one though. Probably that is true for India or let's say Calcutta. But that's always not true, because if you need insurance, definitely you're going to go there and buy, especially to save your tax. Okay, so I'll give you an example. So it's not probably completely true, but it is somewhat true. I've done a project. A project was for China. Okay, and the product was toilet papers. You know what is a toilet paper? You understand, right? So what we have seen that every time you go into a supermarket, 10 brands out of, I mean 7 brands out of 10 brands which are on display are on some discount. People actually don't buy anything if they are not giving you discount. Actually they do not have anything like loyalty. People don't care about much about, you know, the quality, whether it's perfumed or not. You understand why? You're just going to rub a part of your body and throw it out. Why do you care for the quality? Okay, so people always buy it in bulk, and they always look for discount. If you give buy one get one free, they are going to buy it. So if you give a same amount 50% discount, they're not going to buy. That's a psychological effect. That's what the study told us. Okay, so it theoretically it's possible. So essentially what regression tells me, that what is the effect of each variable of sales individually, price, festival, competitors price, promotions, and what is the relationship, whether it's a negative or positive. I mean to say, if I increase the price, what's going to happen to sales? If it decreases, then it has a negative. The coefficient will be negative, and the coefficient's job is to quantify that. Here 2.5 minus 2.5 means if I increase my price by 1 unit, then the sales will go down by 2.5 units. And whereas I have festival, so if I increase the festival by 1 unit, so the sales will go up by 15 unit. Now here it's a good time for you to ask me a question. How can I increase the festival by 1 unit? Can you increase the degree of Durga Puja by 1 unit? Probably you cannot. So it tells me, it reminds me, it's a good time for me to discuss something about dummy variable. There is something called dummy variable. Okay, well that's I showed you with an arrow the relationship. Now there's something called dummy variable. Okay, this is the multiple regression. So this is how it shows. I've already discussed. Okay, see your price, competitors price, promotion, seasonality. So can you tell me what is this error? Okay, not on the system error, but what I've written. Error is, see, I predict that this will be the sales. Okay, yes, residual, but essentially what does it mean? Yes, exactly, not correlation. So I not correlation. See, it's so I always try to put it in very simple language. I am scared of such bombastic words. Uh, See, I predict. Okay, let's say your sales was 10 units. Now I predict what will be your sales. Now, do you think I can predict absolutely correct? No, there will be, I will be overestimating or I'll be underestimating most of the times. So the difference, the amount of inaccuracy, what is the difference? So if I said error is the sum of variables which we do not consider in the linear regression, uh, well, that's correct, but that's a complicated way of saying it. But let's try to put it very simple. Yes, I understand. So definitely there will be some variables which we have not considered. Definitely they will be there. Some will be there. But essentially, it means that the prediction, the difference between our prediction and the observed values. So how much inaccuracy I have, okay, that is your error. I'll talk about the error later on, but for the time being, let's discuss the later part, I mean the earlier part. So I was going to tell you something about dummy variable. Okay, now what are these dummy variables? Can you tell me what are these dummy variables and why do we require? Well, that's true. Hmm. But why to represent the non-economic variable? Devarun, you're so very great with the words, but just put it very simple. So even I always say I get scared. So non-economic variables such as sex. Okay, you mean to say categorical variables? Okay, that's correct in terms of measurable units. Yes, that's correct. So this one seems to be a correct one. So what you cannot measure, I mean to say, yes, that's correct. So I understand. Essentially, you all understand. So if there is a categorical variable, just like as he correctly said, no pointed out sex. So I mean I cannot go from one to two, from male to female. So I just try to to represent subgroups of sample and study of the sample in the study. Well, not subgroups. I mean, this is not the correct one. So I'll tell you. So you all know. I understand. You all are correct. So if I have an education or a sex, whereas I have male and female, so if I want to know the effect of male over female, okay, I mean unlike price I understand if you increase the price by 1 unit from 3 rupees to 4 rupees, but you couldn't possibly do that in terms of a sex. So you cannot increase from male to female. So what is the effect what male has over female? So that's why we create a dummy variable. I mean to say, so let's talk about festivals. Okay, let's say we have 12 months. Okay, these are months of the year, and I understand, okay, these are the months where I have festivals, and I do not have anywhere else my festive period. I do not have anywhere else. So what I do, I create a dummy variable where I'll be marking all the festivals as 1 and rest as 0. So why I do that? Because when regression, the algorithm will be uh, calculating the effects. So what it does, it looks, so here all this period, let's say I have the effect of price and promotion Okay, everywhere I have the effect of price and promotions. So it gives the effect to price and promotion. It quantifies every month, right? Now during this period my sales, let's suppose for simplicity everywhere my sales is in the range of 11 to 15, 10 to 15. Okay, 10 to 15. What happens during the festival, it becomes, let's say, 25 to 30. This is what happens. Let's suppose you do not have the dummy variable of festival. So what linear regression, the algorithm does, it looks how much effect price and promotion has over a period of time everywhere. So, and whatever effect it finds out, if it averages out and gives the coefficient to price and promotion accordingly. Since this is there is an incremental sales and we do not have anything else to account for this incremental sales, what regression does, it has an additional increment. It will give that additional effect to price and promotion itself, because it has, I mean, nowhere to distribute the effect, so it cannot keep the effect to its own. So your coefficient of price and promotion, whatever other variables are, becomes inflated, which is not correct. However, if you have a dummy variable like this, regression will calculate the effect and looks, these are the incremental cells and you also have a dummy variable over here. So it will calculate the effect from here and it will give the same effect over here to price and promotion, and the additional incremental effect will be will be attributed to your dummy variable, that is festival. Okay, so I'll give you an example from one of my study what actually had happened. uh, it was a project of Thailand. So we had seen, so whenever there were some promotions going on, so the sales were actually, for some of the periods, were actually having a very high peak. Okay, but we couldn't understand what was the reason. There were certain promotions, I mean, there were certain times where whenever the promotions were going on, the sales were very high. Otherwise, for the other rest of the period, we didn't have such a peak in the sales. So we were confused. So what exactly was happening? And the coefficient of the promotion what we are getting was pretty high. We could actually understand from the market knowledge that couldn't be the correct scenario. So when we delve into the study, what we found out, when the big retailers like Tesco, Carrefour, there were big retailers, when they were actually promoting, the small retailers, the kirana stores, they also go into the market, go into the store, and they'll buy in bulk, and eventually they'll be selling the same product from their kirana stores. So actually they were having a double counting. Those were not actual sales. The small retailers were buying. So what we did, we created a dummy variable of bulk sales only for those periods, and then we got a correct coefficient, we got a correct effect. So what do you think? It has the effect of both. It also has an effect of the festival, it also has an effect of promotion, and it probably, I would have calculated two promotions, one is normal promotion and one is extended promotion what they have done. So I also need to understand what is the exact effect of the extended promotion, probably which they had not done in the last year. Just for example, they have done some promotion, let's name it as Diwali Dhamaka sale. So what is the exact effect of Diwali Dhamaka sale? Does it have any effect at all, or it is just having the effect of your normal promotion WhatsApp Snapdeal does? So I need to understand what is the effect of for each and every variable. One is festival, one is normal promotion, one is Diwali Dhamaka offer. If I get to see Diwali Dhamaka offer has a higher coefficient, then I probably tend to do this thing more. And what else? I also need to understand whether Diwali Dhamaka offer only has its effect when it comes to Diwali. So I mean to say, when it is used in combination, it might so have happened. It's a time for me to tell you another good example. So during the so you must be visiting all the supermarkets, so you can see well, there is a buy one get one off, okay, or maybe if you buy something you get 20% extra, all the different promotions. And you also get to see there are placards given there. So written as Kisan Jam, buy one get one free. You get to see the placard. So the manufacturers, the companies, they need to pay to the supermarkets in order to put up those placards. It's not free. Now it has been observed that you only give an offer that buy one get one free, people will not be interested because they don't know that. How am I supposed to know which product is on offer in this whole supermarket? So I couldn't possibly go and find it out for each and every product. But if you put up a placard, so it attracts my attention. So these type of offers, buy one get one, acts much more influential way if it is combined with a placard. So we advise our client that always put up a promotion along with a display. Otherwise it loses its luster, it loses its charm. So see, one of the same thing, you're actually giving a promotion, buy one get one, but still it is not having its effect because people are not aware of it. So many a times, yes, artwork, but actually I mean the information is more important here. So you are aware that okay, there is a promotion. Otherwise, I mean, there are so many jams. So you probably were not aware there is a promotion going on. So that is also there. Artwork is also there. So they have separate department how to make it attractive. But essentially you can, I mean, you are using it in combination of other promotion. Then it becomes effective. All right. So now you understand what is dummy variable, right? So it is also called design variable, Boolean variable, proxy variable. These are all different names for dummy variable. One and the same thing. Now comes the model validation. Okay, before we go to the model validation, it's a good time for me to start a case study. So enough of theory, you must be boring, you must be bored. So let's look at a case study or real life case study. See, there is an insurance company, okay, so they have a data like these are the policy numbers for different people. Okay, this is an auto insurance company. You understand what is an auto insurance company? What does it do? Yes, car insurance. Okay, so whenever you, yeah, please come. So whenever you bang your car, so you can claim money to them. So these are the policy numbers of their different customers. These are the age. This is the years of driving experience. So for, these are all different customers. This one, you understand, all the different rows. So what is the driving experience they have? Each one of them, their customers. This is now how many vehicles they are owning. 1, 2, 3, 4, 5. This is the gender, whether it's a male or female. Okay. This is the married and single. What is the marital status? This is the age of the vehicle, and this is the fuel type, whether it runs on diesel or petrol, and this is the losses. Losses means how much claims they have made during one particular financial year, how much claim they are made. So I'm doing this project from company's point of view, that's why they are calling it losses. For you guys as a customer, these are all your profits. Okay, so but I'm doing it from customer's point of view, so I'll call them as losses. Now the objective is, the business objective is that so these are different losses they have incurred, the company. Now they want to understand what are the factors, okay, which actually influences the people to go claim for money. Because if I can get to know if some person, let's say if married people tends to claim more money than the bachelor or spinsters, then I'll charge a higher premium to the married people. Okay, so this is kind of true, because always the married people, they have a stress. So just like me, they are always in stress. Okay, the data is saying so. Okay, so no offense to the bachelors and spinsters. All right, so they want to know, so what are the variables that is influencing my losses, and if yes, then by what is the relation, negative or positive. So if I can get to know what are the things, then probably it will be easier for me to charge the premium. You understand the business question? So here, if I try to do a linear regression, these variables, how they are actually affecting my loss. So loss is my dependent variable, and these variables are my independent variables. I'm going to predict. Okay, all right, so let's do it. So actually I have already written our code just to save time. Okay, these are the libraries. Yeah, I'll yeah, yeah, I'll tell that. So don't worry, I mean, so you'll get to understand. So what I'm trying to do first, what everyone does, I'm trying to import the data set into R. I mean, that's it. It's so very simple. Okay, so far I have just imported the data into R, so I can get to see what are the variables I have. See, these are the variables. So I'm just checking whether all my variables have been imported properly or not. I have not done anything else. Okay, now we have something as gender. Yes, you can run a regression in Excel too, but R and SAS, it is much more advantageous, because so it gives you a comprehensive output, so it's very easy to interpret the outputs in R and SAS other than Excel. But of course you can do it in Excel too. So see, we have a gender like male and female. So as we discussed, we need to create a dummy variable out of it. So I'll mark one of them as 1 and the other as 0. Okay, so I have, this is the just a code, just if else code. I have marked all the female as 1. Okay, so no offense to the male this time. So our chief minister happens to be a lady, so I have to do this. All the female is 1, all the male are 0. Okay, yes, I'll come to that, Gaurav. Fuel also I'll be doing that. Yes, so I have created a dummy variable. Let's see it has been created properly or not. Yes, gender dummy. So wherever I have male, it's 0. Wherever I have female, it's 1. Okay, just a coding, that does not mean male as 0. Okay, so once we have the dummy variable, there is just a replica of this gender. So I do not need this gender anymore. I've just copied this, I just renamed this as 1 and 0. It will be easier for me to interpret, that's it. So I'll be dropping this variable gender. I don't need that. Similarly, I have a fuel type which is petrol and diesel. I'll also convert it into a dummy variable like 1 and 0. And I also have married. I'll also convert it into married as 1 and single as 0. Simple enough. Any question so far? And I'll also drop the variables, original variables which I had. So far any question? So I mean there shouldn't be any question because I haven't started any analysis yet. Just this is the data preparation what I am doing. Now I am ready to do. Now what you do, actually you need to split the data set. Why I need to do that? Because if you are doing it for a client, let's say you build up a model, you also need to test that. Okay, so how well you have uh, developed your model, but in order to test that you need to have some data. So you couldn't possibly go back to your client and ask, okay, give me more data, I'll test. Okay, your client is going to throw you out. Whatever data I had, I've already given it to you. So do you think I'm a data bank? So whatever data you have to manage your test and developing your model into that. So what I do, I split the data set into 70%, 30%. On 70%, I'll be building my model. On the 30%, I'll be testing my model. Yes. No rule. No rule. It's up to you. You can go even for 71%, 29%. It's just up to you. Okay. So this is just happens to be my favorite number. I just done that. So usually people do 70%, 30%, or 60%, 40%. Depends on the data. So if you have a very large data, you can afford to go for 60-40. Okay. So I just yes. It is same logic for all analytics test we do. No, this is not any logic. This is just you're splitting up your data set. For some part you are developing your model, for some part you are testing. You could have done it as 60%, 40% as well. If you have a very large data set, you can also do for 50-50%. Depends on incidence or occurrence. No, not at least in linear regression. So sometimes we get to see that for logistic regression, but not here. Okay, I've just logistics, yes, sometimes yes, but not here. Now we are uh, just went away. It's better to divide the data always for this accuracy of work. Yes. Actually, when you are developing a model, you always have to divide. When you are only validating a model, you do not need to divide it. But now I'm showing you how to develop and validate both. Okay. All right. Now I have a data set as original data and test data set is test data. Okay. Now what I do, I just run a linear regression. Now it's a good time to ask you, do you think, I mean, these are also my variables. Tag is the serial number. Policy numbers, these will be important for our model? You don't think so, right? Because these are some, numbers. How it's going to make any difference? But nonetheless, I can keep them in my model. Because if there are a lot of variables, I don't know which is important, which is not. I can keep them. If you are very confident, you can chuck them off beforehand also, but you can keep them. So I've kept them for the time being. Okay, I have policy numbers, tag, everything. So I run a linear model, a linear regression. So this is the output what you get. What is the first thing you get to see in the linear regression? No, that is not the first thing. If you are learning it for the first time, okay, what is wave statistics? Yes, that is the ANOVA. Gaurav, p-value comes later on. Of course, the experienced one doesn't look at the ANOVA, but the p-value. But you should look at the ANOVA. At least have a glimpse of the ANOVA. What does the ANOVA tell you? What is the ANOVA tells you? not significance of the regression line. Now, I'm looking for the technical part. What is the null hypothesis of the ANOVA here? ANOVA tells you, then what does p-value tests? Not that. What ANOVA tells you, there is a null hypothesis that all the coefficient of the variables, of all the independent variables, are 0. That is the null hypothesis. Okay, you said 1. You said the coefficient is 0. Null hypothesis, all the coefficients are equal to 0. Okay, and the alternate hypothesis is at least one of the coefficient is not equal to 0. So if I want to put it simply, yes, Shomya, that's correct. So if I want to put it simply, what you need to see, if this ANOVA has to be less than 0.05. If it is less than 0.05, then you are okay, you're cool about it. So this model is worth something. Then what you get to see, the R square and adjusted R square. This is what the predictive power of the model. It ranges from 0 to 1. Closer to the 1, the better the model is. So here we can see, so it is about 73%. And the adjusted R square should be very close to R square. So it is 72%. So it's okay. Then what you see, we have in ANOVA we have tested at least one of the variable is not equal to 0. But it doesn't tell me which variable is equal to 0 and which is not. This is what it tells me. So if the p-value is less than 0.05, then that means the coefficient is not equal to 0. So just to put it simply, what you need to do, you just need to see, R is very helpful. So wherever the significant variable, it puts a star beside it. So wherever you do not have any star, it means there is a problem. Okay. So wherever you do not have any star, you just need to chuck them off from your model. You see, first thing is tag. Tag was anyway useless. Still, just I wanted to keep it in a model to show you. We have tag, we have policy numbers. So what I do, I just remove the tag and policy number and rerun the model. Still, we can see the years of driving experience, number of vehicles are still insignificant. I also need to remove them. My idea is I need to have all the variables where I will have all the stars beside them, or the p-value is always less than 0.05. So I'll be removing them also. Okay, I just did a couple of more iterations, but I'll show you the final model. You have to just remove them one by one. Now I can see all my variables have become significant. So this becomes my final model. Okay, your R square is 72%, which is quite good. 72% means quite good. Okay, your ANOVA is anyway significant. Selection method, stepwise or forward, yes, I did not use it because I do not have so many variables over here. Okay, I mean, your stepwise regression works when you have a lot of variables. Here I did not require to do that. Otherwise, stepwise regression doesn't have any other advantage. And I mean, of course, if you want, you can do that. But you know what happens usually? So in real life, you will always be running short of time. So you do not have the luxury of doing everything what you have read in theory. But if you have time, you can do that. Now, what you need to see is there is an assumption testing, but usually we do it first. That is multicollinearity. You understand what is multicollinearity, right? So multicollinearity is checked by VIF. In VIF, what do you do? What is the value of VIF? The thumb rule should be, what is the permissible limit? I mean, it depends on industry to industry. We take it as 2 in financial models. 2. So wherever I have 1.5, Gaurav, you're too strict about it, but you can also have it as 2. Yes, 1.5 to 2. So we do not have any variable which is more than 2. So we are okay with it. So it is within the permissible limit. Okay. Now comes MAPE. Do you understand what is MAPE? Map is, it tells you, so you have predicted something, right? You have predicted something for your losses. Your map is how deviated your prediction is from your actual values, whether they are 10% deviated, whether they are 20% deviated. Ideally there should be 0% deviation, all the same ideally, but that never happens. So how deviated they are. So this is just a code. If you run them, so you can see the map is 49%. So it's weird. It's horrible. It's absolutely horrible. Okay, 49% deviated. But I mean, this is the data which I have. I cannot do anything about it. I couldn't possibly go and change the data. Okay. No, the original and the predicted. Okay. I mean, we used to take it as 10%. Anything less than 10%, it's okay. Okay. Now you also have something called okay. Before residual analysis, I'll just quickly show you the assumption testing. So there are some assumptions which needs to be tested. So these are like the building blocks. So on these assumptions, so my whole model is standing. So my assumption is whatever I am saying you are understanding. That is my assumption. So if you do not understand my teaching, then the whole purpose is kind of defeated. So same thing goes here. So if the assumptions are violated, the model doesn't stand. Okay. So the first assumption is auto correlation or serial correlation. All the error values are not correlated to each other. So it's very easy to easy to test. There was a gentleman, some known as Darwin Watson. I don't know whether they are two gentlemen or single gentleman. Somebody was there, so they had invented this test. Darwin Watson. Okay, two gentlemen. Thanks, Devarun. So, okay, if you do the test, okay, when R is taking a little bit of time, yes. In this test, what you need to see is there is Darwin Watson statistics. If this value ranges from 0 to 4, if this value is 2 or very close to 2, then you can safely assume the errors are not correlated. I mean, that's exactly what you want your model to be. The errors are not correlated. If this value is very close to 2, and you also have a p-value, there's a p value by which you can judge objectively. Your null hypothesis is the residuals are uncorrelated. Your p-value is the residuals are not correlated. So if your p-value is more than 0.05, so you fail to reject your null hypothesis, you can safely assume, okay, my residuals are not correlated. So I'm okay with this one. So here you are okay with this one. Just simply putting it, this p-value should be always more than 0.05. And these Darwin-Watson statistics should be 2 or very close to 2. Okay. So this much you can remember. Right? All right. Next comes your homoscedasticity. Constant variance. This is another assumption. If you do the test, okay, here the p-value should be, again here your p-value ideally should be more than 0.05. Okay, only this much you need to remember. The p-value should be more than 0.05. However, we do not have a p-value which is more than 0.05. So this assumption is violated. So we cannot do anything about it. I mean, that's the data which is saying me. Okay, again, I couldn't possibly go and change the data just to make it significant. The data is not good. I'll tell you. I'll tell you. I mean, if this happens, then what do you do? Then the last one is your normality. The errors, the residuals, what we have got should be normally distributed. Again, you do the test. You understand what is Anderson-Darling test? No? Okay. There was a person, again, I don't know whether it's a same person or two person. Okay, Anderson-Darling. Yeah, please come. So, he used to tell us if the p-value is more than 0.05, okay, then you consider these residuals are normally distributed. But we are unfortunate, this time also the p-value is less than 0.05, so we can assume, we can decipher that the residuals are not normally distributed. So again, this assumption also gets violated. So out of 4, we have only 2 assumptions which are violated and couple of others are not violated. Okay, this becomes your final model. Okay, one more thing, there is something called residual analysis. So what is residual analysis? So you must have heard the term outlier. What is outlier? Any data which is away from the rest of the data set, that is outlier. But this one is a more sophisticated way of finding outliers, and this is also called sometimes influence. Influence means if you have a single observation, single data point which is actually affecting your model, a single data point. How do you test that? Yes, leverage. Yes, leverage means leverage in statistics or leverage literal meaning. Statistic, yes, definitely it comes. But the most popular is the Cook's distance. Okay, so you just run this code and you will get a value known as Cook's distance, a series of value. So what you just need to look at is, okay, I'll just show you how to do it. So this is your data, this is your prediction. Okay, these are your predicted values and these are your actual values. Okay, so you compare them to identify your map, and as I said, the Cook's distance, what you need to see that out of all these values, do you have any value which is more than 1? Okay, if you have anything more than 1, let's say this one is 1 or 1.2, let's suppose if you have something, then what do? Do you just delete that? No, you don't. These are all real data, you cannot delete them just like that. What do you do? That means this row of data is somehow actually making your model misleading, influencing your model in some adverse way. So you just don't delete it, but you delve into the data and look what exactly had happened. And then you have to take the consent of your consultant or client that should I delete this data? You just don't delete it on your own, just to save your own soul. Okay. So these are influences. This is how you check it. All right. Now, just the last part. After you have done everything, how to interpret. So you have done a lot of things, but how to interpret? So do you go to your client and you just tell him, okay, this is your coefficient. The client will say, so what do you want me to do to interpret? So you have to interpret in layman's language. The layman's language is the estimate, whatever you can see, estimate or the parameter estimate. These are your coefficient. Wherever you have a negative sign, it means it has an inverse relationship, negative relationship. So let's say age is negative. That means as the age increases, your loss goes down. So you become more experienced. At younger days, you tend to be more rash. At your mature age, you tend to be more sensible. Okay. Now let's look at married. Okay, again this one is negative. We had coded married as 1. So as you tend to go from marriage to bachelor, so you tend to claim less losses. Okay. Okay, I am not saying that, the data is saying so. All right, let's look at the gender. All right, it's scary. So we had coded female as 1. So the male tend to make less losses than the female. Okay, again, once again, the data is saying so. So don't hold me responsible for that. Yep. These are dummy variables. Mhm. Mhm. Here it will always be always calculating for the one value, the one, not for the zero. One means true, zero means false. Yes. Now tell me, what if I have three levels, 1, 2 and 3? Then what's going to do? Then it will calculate for 1, it will show you. Rest of the things 2 and 3 will be shown to you. So you can see 1 becomes your base. Okay, this is how you interpret. And whatever you have done, the same thing, you need to do it once again for the test dataset and see what happens to the test dataset. The same statistics, same thing, no difference. So this is what concludes the session. So sorry guys, I have overestimated the time by 4 minutes. So yes, you can ask questions. So any question, if you feel so you want to know anything, yes, from you also. Any question? Yes, I just forgot. Now, what if your assumptions are violated? What do you do? Do you scrap the data? Do you go back to your client and ask for more data? Leave the job? I mean, these are different options. Okay, take a leave. What do you do? Okay, four options are there. K, B, C. Pardon? Okay. So you rack your brain or you bang your head. Okay, what happens if your violations, your assumptions are violated? That does not mean your model is wrong. It means the same model cannot be generalized with the other dataset. It works fine with that very dataset. For this data, this model holds good, but I cannot use the same model with other dataset. Do you run the analysis on the p-value and degree of freedom, etc. as well? Yes, p-value has already been calculated. So that's exactly what I showed. Okay, there were p-values. These are the p-values, and degree of freedom is calculated in order to find out the p-value and t-value. So you do not have to calculate the degree of freedom on your own. So everything else will be done by the software. Okay, does that answer your question, Shubhrajyoti? For gender, female has negative impact on losses, right? Not really. So if the gender is negative, that means male are claiming lesser losses than female. So if it is a female are claiming 46 rupees more losses or claims than the male. If I test my assumption first, then develop my model, I am afraid you cannot do that, because unless and until you develop a model, you do not have anything to test your assumptions on. The assumptions are tested on the model itself. What if the model is not valid for validation data? Uh, what do you mean by the not valid for validation data? Do you want to say that the assumptions are not valid? Uh, Okay, could you please just go one by one? So, I'm a slow reader. So if your assumptions are not valid, then it means that the model cannot be generalized on some other data set. But that does not mean your model is wrong on this very data set. Okay. So Shubhrajyoti is saying, do we have to run analysis on the yes, Shubhrajyoti, I'm afraid you have to run the analysis on the test data set as well. I mean, by male 0 and female 1, the everything remaining same. So you cannot change that. We have a large intercept. Large intercept doesn't do any harm. That's the intercept which your software has created. And just in case if you do not have an intercept, your model becomes biased. Okay, that is the out of the scope how it becomes biased. I do not have time to discuss about that. But that does not mean if you have a large intercept. So it's no, I mean it's not going to do you any harm. So, I mean, that does not mean that you cannot explain the largest effect. No, that's not correct. So, if we multiply the coefficient, will not impact on losses. So, I mean, no, not like that. So, -4 means if you increase the age by 1 unit, your losses are going to be decreased by 4 unit. It's a negative relationship. Similarly, in gender, if you increase the gender by 1 unit, that means if you go from 1 to 0, that means from female to male, your losses tend to go down by 46 units. Okay? I'll 1 to 0. Yes. All right. But for female, it will give negative value, which will reduce the losses. No, for female it's not giving me negative value. I mean, for let's consider the continuous value like age. What does age mean? If I increase the value of age by 1 unit, the losses are going to be reduced by 4 unit. Similarly, if I increase the gender by 1 unit, so I couldn't possibly increase the gender by 1 unit, but what I can do from gender going from 1 to 0, 1 is female, 0 is male, from female to male, then the losses will go down by 46. Okay, does that answer your question? Right. So that's great. So anything else apart from asking why males are making less losses? I don't have an answer for that. Okay. So any questions? Or we should conclude the session. So, I mean, the last question I'll ask you, did you understand anything what I have just told? So I always ask this one, did you understand anything? If you have understood anything, then I'll ask you, have you understood something? A little bit more than anything. Okay. So I couldn't possibly discuss a lot many things. I had to skip just, due to paucity of the time. So probably next time I'll discuss those. I mean, in more detail. So regression cannot be done in 1 hour, but still I just tried my best. Thanks guys. Thanks a lot. Thanks for joining us. Yes, one thing you can ask me. Apart from the codes, as I have not done R yet, I was okay. Thank you, Devasrita. Thanks a lot. Yes, for the R code, so you can join us, so we can also do the map cooks test. I'll do that. I'll just send you. I'll try to send the codes to Pratik and he can circulate it. Okay, so he'll be doing that. All right. Thank you, guys. Yep. Bye.
Guys, thanks for joining. The recording of this session would be available on our YouTube channel. I'm just sending the link over here.
Okay. Thank you, Pratik.
Thank you.
This is Vishal here.